we're going to be continuing with polar coordinates. Right now what we're going to do is we're going to do what's called a unit circle right here and kind of help you understand how to go from degrees to radians. We talked about this yesterday. We're just going to quickly go over this right now. We're going to start at 0 degrees. And as I do it, I'm going to label. This is right here. This is 0 degrees. Then I'm going to go up to 30 degrees. I'm going to label this 30 degrees. Then I'm going to jump to 45 degrees. And as I label these, you'll be able to label it with me, okay? Now these are, this graph right here is not going to be perfect, but these are approximate, at approximately 60 degrees right there. We're going to go to 90. And we're going to jump to 120. And we're going to jump all the way to 135, which is not that big. And we're going to go to 150. And we're going to go to 180. Now after 180, we're going to jump to 210. Then we're going to go to 225. Where are you going to go down? Run out of room. No, I have to. Keep going down. So after 225, we're going to jump 40. Hopefully you can kind of see the pattern here. Like I ran out of room. We're almost done. Finally, you end up at 3. 60, and we're going to stop. Because everything else just repeats right after that. So this is 0 degrees, but it can also move it for 360 degrees. Now, I want you guys, we're going to convert all of these degrees to radians, so you know exactly where you are on the unit circle if you're dealing with radians, okay? The first one's easy. You're going to write 0 pi. Okay? Anytime we are at certain 45 degree angles, I want you guys to be able to see certain pattern. So we're going to do all the 45 degree angles and show you a pattern that goes with anything that jumps up by 45 degrees. So I'm highlighting all of those in green. So all the green numbers jump from 0 to 45 degrees. Now here's the cool thing. Check this out. In radians, every single time you go up 45 degrees, you go up pi over 4. So this is pi over 4. So if I go up 45 degrees, that's going to become 2 pi over 4. And then this becomes 3 pi over 4. This becomes 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And finally, last but not least, we get 8 pi over 4. Now, some of these fractions reduce, right? Not all of them. Does 7 pi over 4 reduce? No. Does 8 pi over 4 reduce? Yes, to 2 pi. So we will reduce these at the very, 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 very end. Okay? Now, the next thing I'm going to do is I'm going to highlight everything that goes up by 30 degrees. 30, 60. Now, if you went to 90, that would also share the little purple spot right there, because that would share it right there. 120, 150, 180, 210, 240, 270, 300, 330, 360. So you see how the pi over 4s and the 45 degrees and 30, they kind of line up at certain points on the graph. All right? So we're counting up by 30s. In radians, every single time you go up by 30 degrees, you actually go up by pi over 6 radians. We talked about how to convert from radians to degrees and from degrees to radians yesterday. Okay, so this is going to be pi over 6. This is going to be 2 pi over 6. Right next to this one, I'm going to write 3 pi over 6. 4 pi over 6. That's 5 pi over 6. This one is 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, only 2 more to go, 11 pi over 6, and finally 12 pi over 6. So just like the other ones, some of these reduce, some of them don't. So we're going to come up with the final answers. I'm going to put all of the final answers in blue. So all my final answers. Right now, you can be guaranteed that if you're at 0 degrees, you're at 0 pi radians. If you're at 30 degrees, you are at pi over 6 radians. If you're at 45 degrees, then you're at pi over 4. But what is 2 pi over 6 reduced to? Pi over 3. So understand, if you're at 2 pi over 6, you're actually at pi over 3. All right, now let's look at 90 degrees. Here we go. 90 degrees is at 2 pi over 4. It's also at 3 pi over 6, but both of these fractions reduce to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 3 pi over 4 is reduced. 5 pi over 6 is reduced. What's 4 pi over 4 and 6 pi over 6? They both reduce to just pi. 4 divided by 4, 6 divided by 6 is still just 1 pi. 7 pi over 6 is reduced. 5 pi over 4 is reduced already. We're trying to make this nice and neat. So that I'm like, hey, we're at 225 degrees. What does that quickly convert to? 225 goes to 5 pi over 4. That's why we're making this nice and neat. What is 8 pi over 6 reduced to? Four pi over? Nope. Half of 8 is 4, half of 6 is? Say it again. 3 pi over 6 is at 90. 2 pi over 4, 3 pi over 6, that's pi over 2, that's at 90 degrees. At 90 degrees, you're at pi over 2. 6 pi over 4 and 9 pi over 6 both reduce to 3 pi over 2. This one reduces to 5 pi over 3. This stays the same. This stays the same. And last but not least, you finish at 2 pi. So what I need you guys to understand, all of these right here, I'm going to write the word, all of these have been reduced, also known as simplified. These are all simplified. So it's going to be very important that if you watch this video, that you, if I say, Adam, 315 degrees, what does that equal to in radians? You'd say, that's right. And if I say, ooh, Angela, 300 degrees, what's that in radians? Five pi over 3 is correct. And then I'm like, Caitlin, ooh, 240 degrees, what's that in radians? Oh.
I'm going a little slow.
That's right, it's 4 pi over 3 right there. So this is what you're doing. So right now I'm going to make sure, I'm going to scroll down. You need to pause it. There's the first part. Go down. There's the last part. All right, in summation, I want you guys to understand every single time you guys go up by 45 degrees, you actually also go up by pi over 4 radians. If you go up 30 degrees, that also goes up pi over 6 radians. So that's just a helpful thing to know. You're going from degrees to radians. Every single time you add 45 degrees, that goes up pi over 4. Every single time you add 30, that goes up pi over 6. Here's the quick conversions. If I want to go from degrees to radians, you take whatever theta is in degrees and simply multiply it by pi over 180, and that will give you whatever number of radians that you have. So that's one of the formulas you could possibly use without using the table. If you want to go from radians to degrees, you take theta and you multiply it by 180 over pi, and that will give you the number of degrees that you have. This one will give you the number of radians that you have. So these are the two basic formulas. Remember, theta represents the measure of an angle either in degrees or radians. All right, now it's time to actually do the dadgum assignments. We're going to do some problems together and show you how easy this is. So right now, it says 2.5 comma 0 degrees. This is theta. So how do I plot this point? Well, from the origin, right here in the center, I go over 1, 2, and a half, and I go to 0 degrees, and I put a point. And that is the answer to number 1. If it says graph each point. So you go over 1, 2, and a half, and put a point, and you're at 0 degrees. That is the answer to problem number 1. All right, now what I'm going to do is I'm going to go over here to number 2. We're going to look at number 2. I'm going to label this. There's R. This is theta. Ooh, that says negative 135 degrees. So I need you guys to understand. Positive 135 degrees would put me right about there. Negative 135 degrees starts from here and it goes right about there. So I need you guys to understand. This represents negative 135 degrees, which would be the same as saying a positive how many degrees? Where am I right here? Where am I? Oh, right there. Right here, where would that little mark be? That would be at 200 what? 225, which is the same as a what? Negative 135. So I'm going to put plus 225 is the same as negative 135 degrees. So right now we know this is where we're located. But it says R3. So what you do is you go 1, 2, 3, and you put the point right there. So you go the third ring from the center of the origin, and that point right there represents 3, negative 135. Now we're going to talk about this. What I'd like you guys to do in your journals, I would like you guys to label 3, negative 135 degrees, and we are actually going to find 3 other ordered pairs, other polar coordinates that would get us in the exact same location. All right, so what we're going to do right now is we need, let me go back up here, that's not what I wanted to do. I'll put negative 3, negative 135 degrees right here, which can also be a positive 3, 45 degrees. I want you guys to understand there's different ways to represent a point. Right here, this point is at a 3, negative 135. It's also at a 3, positive 225. Okay? Now, this point right here, if I took this point, which is at a 3, 45, and I move it across, that would become a negative 3, 45. So right here, this point right here is at a 3, 45, also known as a negative 3, negative 135. But if I took this point and moved it across, that would be a negative 3, 45. Now, there's another way to get to this point. I could get to this point saying 3 and saying negative 315 degrees. So this point right here is 3, negative 315. That's if you go which direction? That's if you start here, you go all the way around going clockwise. Remember, clockwise is negative, counterclockwise is positive. So right here, if this is at a 3, negative 315 degrees, then this could say you're at a negative 3, negative 315 degrees. So these are 4 answers right here. These 4 answers all represent what? They all represent this point right here. There's 1, 2, 3, 4 different ways to represent it. In fact, there's an infinite number of ways, but these are 4 common ways to represent that point.